Good morning, everybody. Good afternoon, good evening. So welcome to another Mentor Clojure study group. This is the third one. And this week we're going to mainly talk about structured editing. So that's the way to be able to work with Clojure without breaking the structure, without breaking the brackets. And it also makes things like refactoring a lot easier as well. So thanks for joining us. And let's see, let me just check. If we get time, we'll also cover. Oh, there we go. I'm progressing. Yeah, if we get time, we'll also cover the 4Clojure, some 4Clojure examples as well. So there's a chat window in the broadcast. If you've got any questions, feel free to ask. And those questions will appear when everybody watches this live, watches the recording back again as well. So I'm just going to give a quick overview of structured editing. I'm just going to share my web page. Let's see, there we go, structured editing. There we go. So you should see the my web page. This is just the Practicalli Spacemacs website. I'll put the whole link into the chat so you can see it. There we go. So I can practice using the chat, different windows. So it's in the broadcast chat, which is anybody on the Hangout is different to the Hangout chat, but I'll put it in the Hangout chat as well. There we go. So structured editing is essentially anything that's managed in a structure, and structure is defined in Clojure using something called parentheses, or parens is the short term for parentheses. Parentheses can be quite tricky to say if you're talking about it a lot of the time, so I'll say parens instead of parentheses. And so it's essentially these characters. So it's the list, the round brackets of a list, the square brackets of a vector, the curly brackets of a map, and also the double quotes for strings. So these all help kind of define a structure for Clojure code. That's why you see. That's one of the reasons you see these round brackets everywhere. And one of the very silly criticisms of Clojure is there's too many brackets. Well, that's how you manage the structure of your Clojure code. So you're replacing commas and semicolons and other kind of ways of delimiting your code in other languages with these specific for structural editing parens. There's a really nice video called Parens of the Dead, which can just shows you live code in action. Doesn't explain everything that they're doing, but it's really interesting to see how they're doing it, and you can get an idea about what's actually possible. So we'll cover some of the things that are possible. I'm not necessarily going to go into everything in there, but we'll cover that as well. And there is obviously the structural editing should be supported in the editors that you're using. And so if you're if you have a Clojure aware editor, then it should show you, it should give you the facility to do structural editing. There we go. I'm just going to put the Manny on hold because I can hear you typing and it's getting a little bit distracting. But yes, I'll put it back on hold when you're finished. Okay, so smart parens is how Spacemacs uses it. So Spacemacs is a community configuration for Emacs. Emacs is a very powerful editor, operating system with lots of packages, and Spacemacs makes Emacs a lot easier to use. And one of the things that is included in Spacemacs is something called smart parens, which gives you a smart way to manage your parentheses and sort of managing structured texts. So the nice thing about smart parens is it works for more than just Clojure. So obviously it works for Clojure and other Lisp languages, But you can also use smart parens in pretty much any language or any text you're actually working with in Spacemacs as well. So it's one of the nicer options there. There are other things. There's a classic par edit that people use, and there's also Lispy and par infra as well, and in various states of kind of development. So, and in Spacemacs there's also a Lisp mode, which I'll come and show you a little bit about as well. And maybe not. Did I spell something wrong? I possibly did. You can do a pull request on my book if you want to, or write a comment. But I'll see. Paren party. I haven't come across that.
Yeah, I'll do that.
Okay, cool. Thank you. Right, where was it? Oh yes. So there are alternatives as well. Some of these you'll see in other books, other editors as well. There is so for other editors there is also the options to where are we? Oh no, that's the wrong book. If I go to my other book, which is the Clojure book, which I'm writing alongside this course, there's a whole range of development tools which you can choose from. So the ones I recommend for Clojure development, they include Atom.io, and which has a very nice proto-REPL plugin to do this sort of stuff, and it will allow you to do structured editing as well. There's a strict mode, so you can switch the structured editing on and off as well, which you can do with most editors. Visual Studio Code also has the same thing, which has parens in there as well, and Spacemacs and IntelliJ. So all these kind of tools have structured editing available for you to use. And so how does it actually work? Well, let's just go back to just a tiny little bit of theory. So if you think about your Clojure code as a tree, which it actually is, then you're actually not editing text. You're not moving text around. You're moving elements around inside a tree. So your code is combined of like nested parens as well. So if you just had one simple expression, then it would just be one node of the tree. But so if you were just calling like a function and without any arguments, if you're calling a function and then it had two arguments, then it would have two elements of the tree, and you can move them around. And then if one of those arguments was also had multiple parts to it, then obviously you would go further and further down the tree. And you need to keep this tree structure working correctly, otherwise you'll get errors when the Clojure reader tries to read and understand what you've written in the code. And so you'll have to go and fix it before you can actually execute Clojure. So it is quite important to keep these balanced, otherwise you won't be able to run your code, and some of the features in your editor just won't work until you've fixed the structure. So it is quite important. What else we got? Ooh, I've got a visitor. And so there's some elements here. I'm going to expand on these a little bit more, but actually, rather than doing it in the book, I've got a few examples in Emacs. So I'm just going to share my other screen. I just have to switch over to Emacs. There we go. Switch over to Emacs. So you should be able to see my screen, and hopefully it's big enough. Let's make it just a little bit bigger. So I've got some examples here, and I'm going to start off with the very basics. So as I've mentioned here, Clojure is using parens. And parens is actually, I think it's Dutch for pairs. So you can just think of these as pairs of special characters that we're using to be able to structure our code. And here's an example of a bit of Clojure code. So we've got our main parentheses, our main kind of like expression, and that's got a call to a function. This function is in a slightly different namespace, so we have to kind of give it its full name, and it's got some arguments. One of those arguments is just a string. It's an empty string, but that's also a parentheses as well. And we've also got another argument, the join function, and this one is its own expression, its own form, with round brackets, and then it's got maps inside it. It's got a map inside it, and inside the map, we've got a key and a value, and we can do all sorts of things in here to kind of move that around without having to delete. If we start deleting things, then we could quite easily break our vector or our map or a function call as well. So we want to make sure we keep all those intact. So one of the most useful things, obviously, to start with, is that when you start writing Clojure, pretty much all the time you're going to start by writing a function or a definition, and or a call to a function. So obviously the first thing you have to do is open a bracket, and as you open a bracket, then your smart editing should create the closed bracket for you. So if I keep doing more open brackets, it's going to keep on creating more closed brackets for me. And in this case, Spacemacs is using rainbow parens, so it's actually coloring the parentheses differently, so I can actually see. Well, this is a bit trippy, actually. Whoa! Yeah, there you go. My own disco effects. So you can see fairly clearly where you are, which kind of pair you're actually going through, and so you know where to kind of fit into. So if you were fitting in a different argument in here, again, you might have more parentheses inside there as well, but it's always keeping them balanced. And if I put something in here, then I want to make sure that it's still balanced. So one of the things you can't do is you can't delete. Not let me delete this closing bracket. I have to actually go in and delete the contents of that, and then I can delete it, and so on. So I'm actually deleting from the inside out here, and it's making sure that it's maintaining the structure for me all the time. So that's a really basic part of structural editing. So deleting it saves deleting of stuff, and in here, so yeah, I can go in and if I want to, if my string's too long here, I can just press delete, and it's not. Oops, where are we? Oops. Delete, and it won't delete the strings until I actually delete everything inside it, and so on. So I can just do string hello world. So it makes sure I kind of haven't deleted anything that I didn't want. And same thing with here. I realized I didn't want to add this vector, so I'm just going to go in to insert mode and just delete, and then it deletes the whole structure. So that should be fairly simple to get used to, and that's using, in Spacemacs, that's using strict mode. So it makes sure that you can actually do that. You can actually switch strict mode off, which there's a safe structural editing here as well. There's also a strict smart parens strict mode and strict mode global, and if you have those on, then it'll behave like this. If you really need to delete a dangling parentheses, then, or delete something that doesn't kind of fit into the structured editing, you can switch it off and just delete it. And you can also set up key bindings to override that as well. So why would you want to switch it off? So one of the most common ways of getting your parentheses mixed up or getting extra parentheses when you didn't want them was if you copy paste some code into your editor. That's typically the way you get an incorrect pairing of parentheses, and so you might need to switch it off then if you or just delete what you pasted, and you should be okay. And so we can take it a little bit further. So now we're going to kill expressions. So now I can go in and I've said, well, okay, well, I've got a function here inside my main expression. It's got 2 arguments, and decide I don't want that whole argument. So I could delete the whole, I could delete everything inside these 2 brackets. And then I can delete the brackets, or I can just delete the brackets themselves. In this case, I'm using Control K in Spacemacs, and it goes, and it's gone. And so you could do some very basic structural editing. You could do Control K, and then and obviously you can then paste what you've just cut. So that's like a very simple way to kind of move text around. And obviously I can kind of do the same thing. If I've got a print, I've got a print line debugging statement in here. And if I go in and let's see, to jump to the end of that. So I go in here and say I've got some, what was I going to do here? I'm going to, oh yes, number squared, yeah. So here I'm just going to return number squared, but I might have added a debug line in here, doing very simple, all the classic print line debugging statements. We've all done that in the past, I'm sure. But then at some point I decide, well, I don't need to do that, or I've learned how to use the Clojure debugger. And I can just come in and do Control K, and it's just gone. And some editors will also help you tidy that up. So I can also do DD with clever parens, and it kind of just brings up and gets rid of all the white space and extra lines I don't need. So there's something with Spacemacs when you're using Vim mode. There's something called clever parens, evil clever parens, which makes sure that Vim respects the structural editing of your application, of what you're doing, of your language, you're coding it. Okay, boop. Undo that. So that's a bunch of basic stuff. And then we can also move around our function. So let's see here, we're kind of moving around. In Spacemacs, I'm just doing % jump between the start and end of this expression. And I can also go in to go into this evil Lisp state. Then I can use the evil keys to move around between the expressions. So I'm just jumping backwards and forwards between the start and end of the parens, and that helps me navigate quite quickly through the whole code body as well. So if you're reading your code, you're reviewing what somebody else is doing, you can kind of jump through the code very, very quickly just by jumping through all the parens like that. And then there's the very disgustingly named slurping and barfing. I like to think of these as a bit like if you go into you go get like fast food shop and you get a milkshake, a really thick milkshake, and you have to slurp it. Hopefully you don't have to barf it out at the end because it doesn't taste nice. But slurping and barfing are a way to kind of join and break apart structures of a code as well. So here, so it's really useful if you've made a slight error, or if you're doing some refactoring. It's really useful to use to be able to conjoin bits of code together that should work together. So in this example, I've got I'm calling a map function, but I've put the arguments outside of the bracket, outside of the closing bracket. So actually, obviously, they want to go inside here. I could just delete all and start again, but that would be a bit silly. So I can actually use this idea of slurping. So in Spacemacs, it's space K and then an S. Puts me into this pinkish colored Lisp state. and I can keep on slurping code into that. So in this case, the first thing it slurped was just it was a symbol. It was a name of a function. So it'll pull in symbols, names, references to things, as well as other parens as well. So the next time I do slurp, it'll pull in the vector with everything in there as well. So now my map function will actually work, and I can go and evaluate it. Am I running a REPL? Yes, I'm running a REPL. There we go. So now my code works, and I haven't had to delete anything. I haven't had to delete any of the brackets or anything like that to do it, and I didn't need to copy paste anything either, so it's nice. And I can also do it in reverse. So if I've got, say, I wanted ink, and then I wanted to increment a value, in this case, the values are actually in a collection. So then I realize, oh, I can't just use ink because that only takes one argument. I need to actually map the function ink over the collection. And I type map in the wrong place, and rather deleting it, I can just I can use I can use slurp backwards, so it's slurping in from the left, essentially. So I do space K, and then capital S will slurp it in from the other side. And then again, my code is now fixed and should run quite nicely. You can do the same thing with barfing. You can slurp forward, so you can barf forward and barf backwards. And so barfing is essentially pushing something out. So if I didn't want, so here I've written a let statement. So I'm doing a local assignment, and I've got my local assignment of name being assigned to this value string. And but then I've accidentally put this call to the string function in the wrong place. It's still within inside the definition of local bindings in let, so that's not going to work. So I want to fix that. So rather, I could cut this expression out and then paste it afterwards. But using barfing, I can do space K and B, lowercase b, and it pushes the whole expression, this whole string expression, down outside of the square brackets, and so it's now going to, my code is now going to work. Favorite book is, oh, I didn't write that correctly, did I? What did I miss? I missed off name. There we go. Now it'll work. So yeah. Favorite book is Practicalli Clojure. There are other books, of course, but my favorite book is Practicalli Clojure because that's the book I'm writing at the moment. Okay. And then you can barf backwards as well. Oh yeah, so I've in this expression I'm doing map ink, and actually I realized that I don't want to. I do want to put into vector, but that's not going to work. That's not how the syntax works. So I'm going to I can barf vector out of here backwards. So I do space K, capital B, and then I can either wrap that in there, or I wrap this in there, so it will return a vector. And so I could wrap this in by creating a new parentheses, and then I could just slurp everything in there. So I can do space K, oops, space K, slurp. Okay, and slurp, and then slurp that in as well. So that should return a vector of map. And then I realized, actually, no, I don't need to do that because map will actually, I can use map v instead of map. So I can now just slurp, I can barf that out forwards, and then just use map v in there, and then I don't actually need vec, so I can actually just go and delete it. So a good editor should allow you to go in and actually just delete an expression. So here I'm just going to delete I've got options to delete a word or a symbol or an S expression. So I'll delete that. There we go. And now my code is fixed. We've already seen wrapping a little bit as well. So we've got wrapping and unwrapping, so we can come in and change what's the. So this is a list, and we can go in and change it to a vector, and we could just wrap the list in a vector. I'm not quite sure why you'd want to do this, but maybe there's a yeah, it's still valid because it's the list is a vector. You probably need to quote that if you were going to use that. And one thing I haven't really tried very much of, which is something I want to try and do at some point, is to use these transpose and forward and parallelize these S expressions as well, so you can move things around and do things with kind of the whole structure, move things around, move things into a let, and so on. So I'll come up with some interesting demos around that. There's some videos out there on YouTube as well, but I'll find some more interesting things to show you the next time. But all these things kind of give you the basics of being able to write Clojure very, very simply, very, very easily, and without breaking the structure of it. And then obviously if you break the structure, you break your code, so then you have to debug it as well. There are a couple of other things I'm just going to briefly mention. So there is specifically in Spacemacs and Cider, which is the Clojure editor that Spacemacs and Emacs uses. There's also a refactoring set of tools. So you can go in and select refactoring. So you can select the Clojure mode with comma and R for refactoring, and then I can select C for cycle, and I can just basically convert a collection from. So here we've got a collection that's a vector. We might want to change it to a list, so we can instantly change it as well. So I haven't had to kind of remove the collection and apply another one. I can just basically just change the structure as well. So that's really nice and simple, and change it to a map as well. There we go. Oh yes, there's also narrowing as well, but I've got some videos on my Spacemacs YouTube channel, YouTube playlist, to show you how to do narrowing. Essentially, if I've got a, let's see, where's my bigger function? If we go back to the top, so I've got this function. If I just wanted to just work on this function itself and nothing else, I wanted to change something, I can use the narrowing feature. So I can do space N and narrow to deafen, and it will just show you me this specific function. So now I can work on this. So it's quite useful if you want to change. If you wanted to change so local binding names that we use quite a few times, or any kind of names or functions that you wanted to replace, you can do multiple editing. You can do multiple cursor style editing in Spacemacs, and you can change. You can change names very easily, but just within the context of this function. You can also select a range as well, so you can select multiple functions to do that as well. And then once you've finished, you just basically go space narrow, and then W for widen. It puts back all your edits back into the original file. I mean, they're still there, but it's basically hiding everything else. So it's a nice, neat way to use to just focus on a particular area of your code as well. Cool. Any questions? Is that useful? Oops.
Yeah, I think it's good.
Cool.
I put a question on the video channel.
Is a simple cheat sheet for the shortcuts. So I shall add something to the. I'll add something to the website. I am starting to write kind of more of a kind of guide that shows you that there's quite a few like cheat sheets out there, but I think it's quite useful to get a cheat sheet with a guide. So with Spacemacs, there's this Spacemacs cheat sheet built in. So if I do space, there's Smart Parens cheat sheet, which is what I've got displayed here in this window. So it's just basically showing you what happens if you do all these things. So you can, so backward symbol, forward. So this is just showing you how to move. So if your cursor is at the start, you can basically use that to move symbols as well. Where's a more interesting one here? So here we've got an example of the bath. So if we've got our cursor inside this expression and we call backwards bath, then it'll push the first one out. If we did bath again, it would backwards bath again, it would push the bar out as well. And if we did it again, it would push bars as well. So this kind of useful to have these kind of little diagrams here that show that, or a video of showing it in action. So I'll see if I can add some more of those Spacemacs over the coming weeks to help you learn that. Cool. Anything else? Let me just switch back to the websites briefly. Oh, we've got to press that twice. There we go. Smart prints. There we go. Share that. Ooh, blurry. And is it working? Oh, I have to switch it back onto my on my own desktop as well. There we go. So I can see what I'm showing you. Yeah, so I got some examples here of smart parens actions. So setting the strict mode, so that it makes sure it always respects the open and closing brackets. There is a cheat sheet link there to the Spacemacs one, how to run it as well. And most of the things I'm still learning a little bit to get used to this, but a lot of things are done in this Lisp state. So essentially, you can put it's using the Vim style of multiple states. So you've got in Vim you've got normal and insert mode. In normal mode you're moving text around. Insert mode you're typing text and adding text into the buffer. In Lisp state it's focused on you basically doing structural editing. So you're allowing you to move text around and keep everything balanced. You can still code in there as well. So there's an interesting video that shows you Lisp state in action, and there's a quick kind of some of the key kind of key bindings here you would use for that I've kind of distilled them from the cheat sheet as well, so you can you can kind of use that to help you understand what how to do things in specific Spacemacs. I'll check to see if there's the same thing for other editors as well and add those links in as appropriate. But yeah, there's examples of wrap and unwrap, which I'm going to add videos for. And then there's slurping and barfing, which again, we've just got a video here. Deleting, splicing. Oh, I haven't done that one yet either. So I'm going to add a whole bunch of like little snippet videos for this as well to make it easier. Okay. So unless there's any questions, that's all I was going to cover on structural editing. I think that's a good starting point. If you can get those things mastered, I think trying to master the whole of structural editing all at once, you can spend a whole weekend, but you still actually just need to use it basically on a regular basis, and you'll soon get very comfortable with it. It is different from normal editing. And if you're not used to kind of Vim style editing, then it can feel a bit strange to just not just copy paste things around. But if you put a little bit of work into it, then it can save you an awful lot of time when you're doing Clojure as well. Okay, so last week we covered the Clojure bridge exercises, and feel free to keep on working on those away. And if you've got any questions, then please ask. And as a change, we're going to look at some of the 4Clojure exercises as well. 4Clojure is a website that's got nothing to do with mortgages or buying cheap houses or anything, as it says. But it is all about helping you understand Clojure, and this particular focus is really on helping you understand the functions that are in the core part of Clojure. So what we call the Clojure.core namespace, which is pretty much all the functions and macros and so on that make up the basic Clojure tools that you'll use, the basic Clojure functions that you'll use in pretty much all of your coding. So when you create a project and you start a new REPL, then all of the functions that are in Clojure Core are going to be available to you, and you can use them. And if you ever want to find out what any of those Clojure functions do, you can usually get help via your editor. It'll give you some help by describing what a function does. And you can also obviously go and ask the internet. So if I do a Clojure and then map, then it's going to take me to this Clojure docs website. That's the first link. I click on that, and I can see how I can call map, what are the arguments I can use with map. So with map, I can just pass a function. With map, I can pass a function, a collection, and so on. I can pass a function and multiple collections, and so on and so on. And I can, I can basically pass a function with like an infinite number of collections, more or less, as many as my my stack will comfortably handle. There's a link to the source as well, so you can actually go in and look at the source code of all the functions that are in Clojure Core. And you can see, if we look at the left-hand navigation, it's divided all these up by namespace, and here we're in the namespace Clojure and the sub-namespace Core. So this is all the functions that are available there. And I think there's over 600 functions there to choose from. The nice thing about this website is it gives you examples. So there's community contributed examples in how to use this function. So it's giving you the actual expressions. Sometimes people give a little comment as well, and also it's giving you the answer, so you can see what it's actually returning, the value it's returning. And one other thing that is quite nice that this gives you is if there's related functions to the one you've just looked. So there's quite a lot of examples in this. There we go. Then yes, so it also shows you this see also section. So there's also variations on how to use a map. So there's things like pmap, which is for doing parallelism. So if you want to run map over a large number of immutable data sets, then pmap might be a faster approach. And there's also things that are similar in nature, like juxt and keep and mapv. So mapv is a very similar kind of function. It just returns, it specifically returns a vector rather than a sequence. So even if you're not sure, or you find a function and you think it mostly does what you want to do but doesn't quite do it, then there might be things in the C also that help you find the right function that does the job. So map and reduce are very similar, but map gives you a collection of results, and reduce often just gives you like a single value. So it reduces down a collection into like a single result. Yeah, so they kind of both work. They both take a function and apply it to all the elements in a function, but how they kind of do that is slightly different between map and reduce. So they are kind of conceptually linked, but they are, sometimes you might want to do map, sometimes you might want to do reduce. So why is that important? Well, it's quite useful when you're going through the 4Clojure to just go and have a quick Google of some functions, and if you might find something that solves a problem, but it might be quite big or not quite as clear a code as you want to. So sometimes you can go in and go to the Clojure docs website and find a slightly nicer way or a slightly different way of doing things. Again, this is programming, so there's always multiple ways to do and solve any kind of problems. I'll talk about updating Spacemacs just at the end before I go, but yes, there is. And thanks for the comments about the guide. So let's have a look at 4Clojure. So it's just a website. It's been around for quite a while. There's quite a lot of problems on there. I think there's about 150 more little exercises. Some are really easy. Some are deceptively difficult, and some are just obviously difficult. But there's quite a lot of things there that help you get started. A lot of things are in the elementary or easy level. Some say they're easy and they're a little bit more challenging, but it is good fun, and it's a kind of a relatively safe way to write Clojure. So I recommend that you create a free account. You can just log in. So just register if you don't have one, and then log in. And this allows you to track where you are in your progress. So if you go to the problem list, it's going to show you which ones you've actually solved. So if I just sort this by solved, it's showing me all the entries that all the challenges that I've actually done. I've still got quite a few to actually do, as you can see, but I'm getting there slowly. So these are quite useful for doing at coding dojos, or if you've just got a spare like 20 minutes or an hour, depends how much time you want. So it's quite flexible how much time you can spend on these. So let's just have a look at, what else did I want to mention?
Yippee, I did my first one and I got 11 points.
Woo! Oh yes, we'll come to golf scores in a second. But yes, so if I go in and solve one, so here, if you've logged in, it's going to remember what your answer was. So I could do a very long, answer, which is, oh, actually that's not going to work. There we go. Too many. There we go. I get carried away. So this should still solve it, I believe. Yes, there we go. Whoops. So there are many ways to solve 2, because 1 is always equal to 1, and 1 and 1 and 1 and 1 1 1 1. But that's giving me a golf score of 20. And you can actually go in and view.
That's cheating, John.
Well, golf score is supposed to be as small as possible, so actually it's quite a bad golf score. So if I look at the league, so it showed me that I've had a better golf score previously, and this is my golf score at the moment, which is quite high. But there are plenty of people with a much lower golf score in that way. I could go back to the view code. There we go. Go back to the code. Obviously, I could just I could do something smaller, and that's going to give me a small golf score. But golf scores aren't really kind of like a foolproof way of defining whether it's good code or not, or whether it's idiomatic code. It's just basically counting how many characters you've got in there. And I'm trying to think, what's that? 1, 2, 3. I've got 5. One of the easiest ways to solve whether something is true, though, to actually get back to the actual problem itself, I need to solve this expression. So basically, I need to put in something where these underscores are, and that was going to equal true. And to me, the most obvious thing that equals true is true. And so that will give me a nice small score. So it can give you an indication about how terse, how elegant your code is, but it's only a basic, very rough indication. So yes, don't take, if you get a golf score that's higher than everybody else, but it's a nicer solution, then I think that's good. You don't need to kind of get the smallest solution out there. if you follow people, so in this top users list, there's a whole bunch of people you can follow, and if you go in and select them, then you can actually go in and see their solutions as well. So we're not really going to learn much from this particular solution because everybody's probably going to use true, although occasionally people will use interesting things as well. So true. That's quite complex. I think I don't even want to describe that one. But yeah, that's also interesting. Obviously, not false. So somebody's done that in there as well. So kind of showing that obviously false is the opposite of true. Yeah. Oh yeah, somebody did do that as well. Somebody did do the 1 = 1. Cool. So sometimes you can learn them, but you can only see those solutions once you've actually solved the problem. I'm going to change that to true. So I kind of use that when I'm showing that to people. I use this example as a way to kind of show you there's different ways to solve the problem. And then it's saying compress the sequence. Is that the next one? Oh no, that's not. So you can. There's an easy way to cycle through them. The easiest way I found is just to change the number in the URL. So once you're on the problem, you can just change it and go through. So we'll go through the first 10 or so. That should take us to the end of the broadcast. So we can do some simple math. So this is just basically walking you through. So the first 10 or so, walking you through the syntax. So hopefully you find these fairly easy. So in this one, it's encouraging you to kind of think about how to read Clojure. So I want to find out what this expression is going to be equal to, and it's going to be I'm going to be the sum of minusing from 10 this value. So what's this value here? This value is 2 times 3, which is 6. So I could think about I'm replacing that with 6, and then I'm going to take 6 from 10. Which is going to give me 4, and that's what the answer is as well. So 4 = 4. I could also do I could do 16 over 16 over 4. Is that going to work? That goes in 4 times. So that's a ratio type. I'm just curious to see whether that's supported in 4Clojure, which it is. So that's actually 16 over 4. If you actually calculate that, that gives you the value of 4. Obviously, that's a very silly way of solving it. It's a very different way of solving it. And I could just use the value 4. But again, just to show you, you can kind of very easily experiment with these things as well. And so let's go through number 3. This one's showing you a bit of Java interop. And we'll probably have, if there's interest, we can have a session on Java interop as well later on. But essentially anything that's in Java, anything that's in the namespace java.lang, you can actually use inside a Clojure program that's running on the JVM. If you're using Clojure script, then you would use the JavaScript equivalents of these things, but it would be the same form. So if you've got, I believe that's a static method on string, so you can call this just by using the dot thing. So it's going to call this function on a string object. So in Clojure, if you put something in double quotes, then Clojure is going to interpret that as a string type, and string in the JVM. So we're using a Java string in here. We're using a java.lang.string type for this hello world string, and so on that class, on that object, we can call this method to uppercase. So in this case, we're using to uppercase as a function call, and it's taking the string as an argument, and obviously that's going to return all hello world all in caps, and that's what we're comparing with. So there's got a vote for some more Java interop stuff. Yes, I might need to think about that, but I'll certainly have a good go at showing you how to do Java interop stuff. Certainly makes things like, even like doing things like swing programming, if people are still doing that. The actual or UIs in Clojure in Java. It actually makes it a lot easier to kind of drive those kind of things inside Clojure rather than doing them all in Java, because you can just use like chaining. You can chain these functions together just as they were in a nice, easy way. You don't need to have to use any of the new features of Java 9, 10, 11. Okay, that's number 4. Number 4. List. We've used, you've probably seen me write lists like this. And when you're writing your code, you write lists just by writing the round brackets. We showed that in the structural editing. We pressed it, open round bracket, and close it again. And so here we've just got a list of ABCs. And the quote here is to just show that we want to treat the list as just data. We don't want to execute it. So we're not going to try and call A as a function. We just want to have this as a value. So how do we create this without just typing it in? Well, it's suggesting that we can use the list function. So if we use the list function and give it the same arguments that we want inside our list, then it's going to generate those for us. Blum, 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 and then solutions. I guess they're all going to be the same as well. Blob. Yes, there's nothing. I don't think there's anything different you could probably do with that, really. There we go. 5. Yeah, it would be nice to have next and previous on this Clojure website, but there we go. I'm sure they'd accept a pull request if you were interested. So conj, I think we mentioned conj and cons before. So here we're just conjoining this collection and this value together. So we're basically creating a new collection that's going to have the values of 1, 2, 3, and 4 in it. And the same thing with conj. What this, I guess, is showing you is how it's adding it to the new collection it's creating. So we're going to take this collection, we're going to create a new one. We're going to put the value of 1 in. So we're basically going to take a copy of this collection, and then we put the value of 1 at the front. So we will get 1, 2, 3, 4. And in here, in turn, we're going to add 2. So we put 2 on, so that would be in front of the 3. We put 1, and that would be in front of the 2, and we still get 1, 2, 3. So it's just showing you how conj works with lists, and a reminder that lists are linked lists, so that the most efficient way to add something to a linked list is to put it on the front of the queue, just like stacking books in a queue. The easiest way is to stack the next book at the top, at the front. So the answer is that. That's the next one we can do. 6. Intro to vectors. So vectors for me are kind of the main tools. So vectors and maps are kind of main tools you use for defining your data structures, defining data in Clojure. However, it's very easy. Most of the time that you kind of use data, you can use it as sequences, so that the fact that it's in the list or vector isn't always that relevant, because most of the time you want to just deal with the actual values that are inside that collection. So here we're showing lots of different ways to create a vector or something that's equivalent to the values in a vector. So here we're explicitly calling creating a vector by giving it the like individual values. Here we're converting a list to a vector, and obviously we need to quote the list so we don't evaluate A. And here we're actually doing something different. We're actually just creating a list. But if we go into you go into the REPL and you actually find out that, well, actually a list of ABC is the same as a vector of ABC, so they're actually equivalent. Because when we do the equals comparison, we're just comparing whether those collections have the same value. So we can compare a list of ABC and a vector of ABC, and they're actually equal. Yes, yeah. So it's So it's a nice comment from the from Manny there. Yes, that it's the values that are important. It's not the actual structure that's important itself. I tend to kind of forget that because I'm mainly using vectors and maps, but it can be useful sometimes in certain situations. Vectors conj. So how do we conj onto vector? Again, this is very similar to the conj with lists, except again it's showing you the order where it's actually placing it. So this time conj is adding to the end of the queue as well. So a vector is indexed, and so therefore doing random access is very efficient. So it's very efficient to put something at the end of a vector, whereas a list you would have to traverse all the elements in the vector and then add something if you were going to put it at the end. So that's why you put things at the start of a list at the front. So it's sets. So the most important thing about set, obviously, is whether they're unique or not. They're not guaranteed to be ordered, but then in a set, it doesn't really matter. The thing you want to get from a set is the fact that those values are unique. So if you actually typed a set in and you actually did a set that wasn't unique, then that would cause an error. So Clojure would give you an error if you actually manually typed in the set. So a set is defined by these curly brackets, but with a hash at the front of it. So it's basically saying this isn't a map. This is a set. So that's the syntax and how you would mainly kind of define a set. Although if you're converting values or pulling values in from another function or another system, then you might be more likely to use the set function, and then it doesn't matter in that case if there are duplicates, because the set function is going to extract them all out and just return a unique set of those values. And there's other things here. So if you've got multiple sets, so just like we've seen with Clojure.string, there's a Clojure.set namespace which has specific functions to allow you to work with sets. You could use some of the Clojure core functions, but you might get slightly different results, and you might get a list returned instead of a set. So if you're working with sets and doing like specific things with sets, like in this case, having a union of sets, then using the Clojure.set namespace functions is probably more appropriate for what you need. Where are we going? Oh, we're nearly at just coming up to so I'm just going to do like the first 10 or 12 of these, and then we'll wrap up. So all these are pretty elementary, so hopefully if you've done a little bit of Clojure coding, you should find them fairly straightforward, or they should be fairly easy to look up or even guess from the answers. Here we're doing another set, so we're just conjing with sets. So what happens with conj? So we're just conjing a number on here, and it doesn't matter here where. To be honest, it doesn't matter where conj puts it in the set, so long as it's a unique. So we're not trying to conj 3 or 4 or 1 onto this, then which should cause an error. Then it doesn't matter what order the values are in that, so long as we've got the same values in the set, it's going to be equal. Let's do 10. And intro to maps. So maps are really useful again for helping you model and organize and work with data. Maps give you an extra dimension to your data structure because if you're using meaningful keys, which we are not here, it doesn't really mean anything. I'm not sure if that was 65, then maybe that would be like the ASCII code of A. And yeah, in this case, these keys aren't particularly meaningful, but potentially you could have a very meaningful key here that describes, this could be like, this could be a map of languages, and A could be this could be Clojure is 10, or actually 11 now, and Java is 20 something, and so on. So you could have meaningful names for these keys, and it'll help you understand what the purpose of that map actually was. In this case, we're basically just showing you how maps actually work. So we can type maps in. So I can do a map of, again, this isn't the answer, but we'll do a map of 2 values. And so we need a pair. We can't just use 20, so we could use, I've got 20 apples. I might have, 20, I might have 10 oranges. Boom, boom, boom. And so, yeah, so this could be a map of like fruit stock for my thing there. So obviously when we're typing it, we can just use the curly bracket, but as we're typing it, we need to make sure that we've got key value pairs, and we could just have one key value pair or as many as we want, but they must be pairs. Pairs, haha, not apples. There we go. And sorry, I'm laughing on terrible jokes. So we can also create a map using a hash map function, and this is going to take values. So long as we've got an even number of values, then we're good. We don't have to use these commas here. Commas in Clojure white space, so they sometimes developers will put them in for readability, but to be honest, you'll soon get used to not using commas there. And you can put the hash map onto different lines if you want, if it makes it easier to read. So here we're creating a hash map. Here we're creating a map, but we're actually then calling that map as a function. We covered last time that we can call maps as a function. In this case, the function is taking an argument of b, and so the map says, okay, well at the key b, I'm going to return the value that b is pointing to, which is 20. And because we're using a keyword as a key, so anything with a colon in front of it is a keyword. And the keyword is quite special in Clojure. It's like a symbol, but instead of pointing to another value, the keyword points to itself. So it's a really nice way to look up itself in a map. And so in this case, it's using this keyword as a function with the map and saying, okay, there's the key, so I'm going to return the value. So this can be, again, quite useful in anonymous functions, using this kind of form of using the map or using the keyword or the map to basically extract values from the keys. Let's see what we got to 11. And then how to conj maps again. So we're just conjoining maps. There's quite a few functions you can use for joining maps together. So there's the default conj. I think most people use things like assoc for associating values with a map, and update, where you can update the values in a map for a respective key. But conj is, I think they're showing you this just because they've done conj with all the other ones. So here we can, here we don't have to use a map to conjoin. So as long as we've got 2 values or pairs of values, then we can add those to the map because they fit the map form. So here we're just putting them in vectors. We could put it, this could also be a list with a quote in there as well, I think. And let's see, 12. And then sequences. There's just a couple of ones on sequences. I think we've covered these a little bit as well before, but these are really useful. So sequences are great for just basically treating collections all the same. So it doesn't really matter if you've got a list or a vector here. We're just treating it as the same. So we want the first value from the collection, and that's going to be 3 in this case. Then we got the second, which is it's 3, strange enough. And then we've got a list, and we want the last value, which is 3. So this one's 3 as well. And there's also rest, so we could just get, if we did the rest of this one, we'd get 2 and 1. If we did the rest of, so another way of doing this one, you could do this as, you could do the rest of the list and you would get 2 and 3. And then you could do second, and then you would get your answer as well. So sequence functions are kind of like the basic way you can use to just iterate and play around with specific parts of your data structure. Oh, there we go, rest example. So here we're just returning rest, so we're just going to return that. And it doesn't matter, I mean, if we put this in a vector or a list, they should both work correctly. Right, key. There we go. It should still work. Yay, congratulations, there's green. So again, it's comparing the values in there rather than the types of data structure. And then functions. Would you like me to carry on and do functions? I think I'll do functions. It'll just take another 10 minutes or so, I think. Nobody's saying no, so I'll carry on. And so functions, obviously we've seen a lot
Please do, John.
Thank you very much. Thank you. So we've seen a lot of functions that we're calling. And here we're showing some of the basic ways to also define them. So we're using the very simple form of fn to define a function. But we're defining a function in line. We're not defining a function for our namespace. We're just going to define a function that we're just going to use straight away. And so this might take a little bit of thinking about to read this. So we've got a function here. This is our function definition there. And but we've also got an outer bracket around that as well here. So we're actually calling that function. Oops, it'll be that one, won't it? Yeah, there we go. So we're calling that function that we've defined. So this is a function we've defined. We're going to call it with an argument of 3. So if we could actually, if they were using defn elsewhere, we could use defn we could write a function. Oops, I didn't want to do that. This is why you need structural editing, so you can't delete those things. There we go. So if we were using defn, which is defining a function, we're adding 5, and then I could just replace this call with add 5, and then it takes the argument 3, and then it would be easier to kind of read. But if we were only ever going to use add 5 once, then there probably isn't a reason to write a defn as well. So defn is where you're going to use you're going to use a function more than once. Whereas fn is where you can use functions in line. So you might use that with a map or a reduce or a filter, but you can use them anywhere as well. If you need to do something a little bit more low level, they're quite useful. So here we got a function. It's going to take an argument of 3, but what's it going to do? So this is the argument list it's going to take. So the argument we pass into is going to be represented by x. And so we're going to have the sum of x and 5. So in this case, that's going to be 8. And so that's hopefully is going to be our value, should be our value for everything else. We're doing the same thing here. What's different? Oh, the only difference here is we're not specifying a name. So this is like truly an anonymous function. So this is kind of like a lambda function, an inline function you're going to use. So is this. So why would we add a name? Why would we include a name? Well, we might actually refer back to this function. We might want to call it again. So instead of doing add 5, if we could actually, instead of having this 5 value, we could have a call back to 5 with some more let's see, with some more arguments. So if we weren't just passing 3, say if we're going to pass a collection of values, there we go. 1, 2, 3, and then we did something where we did sort of rest. Of x, and then we could actually call yeah, I'm not sure if that does exactly what I want, but yeah, so basically we're taking x and we're going to add 5. Oh yeah, that might work. Yeah, so we call add 5 with our arguments. So we need to put, so if we're actually going to run this, we would need to do around the end of it as well. I think that's right. So we're going to call this function. It's going to run this inline function with an argument, and it will pass the collection of 1, 2, 3 to x, and then we add. I guess that would be the first of x. We get the first value, and then we're going to add the first value to the rest of the values by calling add 5 again. So first time we would, this first x, this would be 1, and this would be 2, 3, and then we would call this, so this would evaluate to sort of, we'd do, the next time around this would evaluate to 2, so x would be 2, and the third time would actually be 3, and so we'd be able to basically just add up all the numbers in the collection together. So this is essentially how the reduce function works. Basically kind of iterates through the collection and adds them up, so it actually builds up. So instead of so we get to a point where we'd have this would be replaced by 1, and then we'd call this, and it would end up generating another value of 2, and then we'd call add 5 again, and this would be replaced then by 3. We add all, and then we processed the whole collection, and we basically got adding 1, 2, 3 together, so that would return our value of 6. So that's why you would use the name add 5 in a function, in an inline function. But if you didn't need to call it itself, then you don't need to specify a name. And sometimes actually not specifying a name is clearer. If you can't think of a good name for what this is doing, either you don't know what you're doing with this function, or it might just be a really simple thing that's very obvious. So you don't need a name for that as well. But essentially, it's the behavior of this is doing exactly the same thing. Yes, I was elaborating a little bit on the add 5 thing. So yes, so just kind of that example of how to do a reduce was just to show you why you would use add 5, not really on the solution. And it's you can use the really short form here. So using again this hash symbol in front of a list, and so this means we're actually it means exactly the same as this function definition. So the hash and the brackets are exactly the same as this function definition here. So basically saying I'm defining a function, and I'm just going to represent its behavior. I'm just going to say what it does. So it's just this bit of the function. How many arguments I'm going to use? Well, I'm going to take the arguments and put them here. So any argument that's passed into this function is represented by this percentage sign. And so you could use %1 if it's just one argument. You can do %2 You could just use %2 if you didn't care about the first argument. You can skip off %1. But it's basically a placeholder for where the argument or arguments will actually go in your function. And you can put them in any order, as long as obviously they're probably not going to be the first thing, except maybe there might be a keyword. But essentially, this is defining just the behavioral part of the function. So it's stripping out this function and an argument definition and just going straight to the behavior. So if you've got a really simple piece of code you want to run, then this is an easy way to do that. And partial, you probably work your way up to, probably don't use that very much to start with as you're doing Clojure, but it's kind of useful to know it's there. So if you want to call a function with some arguments, but you don't have all the arguments ready yet, so you might just be, if you're just pulling one value out of a collection at once, then you wouldn't have all the arguments available to you, so you will have to wait until you get all the arguments and then you would call the function. So partially saying, okay, this is a partially defined function, so I want to be able to add 5 to something else, but I don't have that something else. But once I get that something else, then I'll run this function, because it will no longer be partial, it'll be a complete function, and I can run it. Is partial like currying? Oh, I like curry. I'm starting to feel hungry. Yeah, kind of. It was implemented differently. So if you compare how Haskell and Clojure do currying, it's actually implemented slightly differently, because I think it's like Haskell, you're only doing one argument to your function, whereas Clojure, you can have multiple arguments to your functions. So currying is slightly differently, but conceptually it's the same. Haskell as well. Oh yes, I know a bit of Haskell, but only a little bit. So yeah, so most of the functions you're going to write, if you're going to write them more than once, you'll use defen. So you'll do defen and then function name, and you'll do the arguments. Oops. And then you'll do some behavior, and then obviously you'll close the brackets. So you'd use that if you're going to use the function more than once, or if you're going to use a function in more than one other function, you'd use defen. If you're just going to do a simple recursive thing, then you would use function with like a name, simple name, and you could call that back again. Or you can just use the short form, the anonymous version of this inline function. And then if you're just doing something with map or filter, and you wanted your own little custom function, then if it was very simple, you would do something. You would use this syntactic sugar of just using hash and brackets. And if you didn't have all of the, if you knew you didn't have all of the function, all of the values there that you wanted to work with your function, then you can use partial. And you could also use this anonymous function to have a more complex version of partial as well. So if you had multiple different things that you wanted to that partial didn't help you manage, then you can use this short form as well. It's quite an expressive way of defining lots of things. 15. Yeah, there's quite a lot of things. There's partial, there's juxt, and there's all sorts of wonderful other functions in here as well. What's this one doing? So I think that's covering all of the yeah, it's covering all of the functions here. Here we're trying to it's just getting you to write a function. So I'll just cover this one and we'll wrap up on that one. So here it's asking us to write a function. So it's giving us a clue about what we're looking for. We're not looking for a value. We're looking for a specific function. And we want to do something here with 2 that makes the result equal 4, and same with 3. So it looks like we're doubling. And there's obviously a hint here because it's called doubling down. So basically we want to take this value as an argument and double it. So here we're defining a function. So we could write this as the longer form. A little bit further. So we could do a function and then take an argument. Oops, it's in the wrong button. There we go. And we're going to take some number, and we want to be able to times. We need to multiply that number by 2, which will double it, and then close the function. That's the longer form, and then we can write the syntactic sugar form, the short form, here by just writing essentially this bit. Although, yes, so here we got the argument, which is in this case, in this example, it's number, and here we're just using percent. %1 works exactly the same, so percent will just take the first one if that's what there is. %1 specific. If you have there's multiple functions, you would do %1, %2, and you could do them in any kind of order. You wouldn't have to do that, so you can basically control how it all looks. But to keep it simple, here we're just taking the arguments and then multiplying it by 2 and returning the result. So obviously this will give us a slightly longer golf score, but it's probably more clearer to read when you're first learning. This one will give us the shorter golf score. What's the difference? Oop. So this is the last one I'm going to do. I'm going to leave you to do some of the 4Clojure exercises there, and we'll cover some specific ones in detail a little bit later on. I'll take a few that are kind of interesting and related to each other. So let's give me a golf score of 22. If we do that, then obviously it'll give us a shorter golf score. So golf scores, again, are not significant. I mean, they're kind of interesting and a little gamification of the whole thing. So I've got a golf score of 6. Actually, it could be an indicator that your stuff is two-tiers, or it might be an indicator that it's beautifully elegant code. It doesn't really guarantee either of those. Are there any other solutions? Again, maybe there are solutions there. They're all fairly much the same. Times 2. Oh, yeah, they're just doing times 2 as well. That's interesting, but it's good practice to kind of do a function. Somebody's used the partial as there as well. So again, there are quite a few different ways of doing it. So for a simple arguments, just one argument, then partial is quite an easy way to use, and some people find that more easier to read than this as well. I think it just depends on your experience. All right. Well, if you can do those like first 15, and then there's quite a lot of other ones out there to play around with. There's over like 160 odd 4Clojure ones to play around with. So feel free to go and play around with it. Hello World. Most of these, like first 20 odds or so, are kind of elementary. And if you go into the problem list, then it'll show you which ones are easy. So it's elementary, easy, and then it gets medium and hard. Oh, I haven't done quite a lot of the hard ones, so I should pull my finger out. Yeah, it's again, it's a really great way to help you understand how the Clojure functions actually work. Sometimes you'll get a problem and it's really easy. I think was it 62? I'm going to try and find one that I just did recently. Yeah, here we go. That was a good guess. So here, it's a bit more involved thing. What it's actually trying to do is, I won't show you the answer. There we go. It's got some maps, and it's asking you to join maps together, which would be really easy to do if you use this function called zipmap. However, it's a restriction here, so you can't actually use zipmap. So that would make you, so you would probably go in and have a look. So here, instead of map, we're looking for zipmap. So you could go into zipmap, and and see what it does, see some examples. Yes, this is what I want to do, but how does it work? You can actually go in and click on the source code and actually go and have a look at it. This is quite a lot of code in here. This is basically all the code for Clojure course. It just take a second or two to jump to the right place, but it will get you there eventually. And here it's just showing you, yeah, how zipmap works. So that might give you a clue about how to do it. But again, this is kind of taking all of the cases. So there's quite there's an opportunity to refactor this into something more specific for what you're trying to do to solve the problem. Because essentially it's just basically recurring and taking the first key and value pair and then calling the next value pair, going around the loop. So it's just basically an iterative call to do that. There are some nicer ways, some nice elegant way to solve this as well, but this kind of source code can give you a clue about how to think about it. Others are kind of more complex. Some of the functions are in here are easy to understand, and some will take a little bit more kind of thought. So sometimes it will help you, and sometimes it will might just confuse you, but that's fine. Some of these, because this is core, some of these do actually use some interesting stuff. Some actually use some interop things there as well, and some of the underlying stuff that you don't really need to learn in too much depth unless you come up with some kind of performance issue that you want to tweak and refactor. Okay, so that should give you enough to be able to solve pretty much all the 4Clojure problems. The biggest thing obviously you'll need is time. Some will take you 20 minutes, some might take you a couple hours. Some you will kind of solve and then come back again and think, oh, actually I could have done that much more easily, or much simpler with a simpler solution. That's fine. That's normally what you do in Clojure code. You create something that works, and then you refactor it, and you come up with something that's actually very, very idiomatic, very kind of like Clojure-y, and solve it. But you don't have to come up with that the first time round. It's very easy to kind of review it and play around with it, experiment it, and try a few different things, and come up with like a nice solution. But all that's happening in the REPL, so you're getting lots of constant feedback, and so it's quite common that you would just basically take these problems and copy them into your REPL buffer and play around with them and experiment in that way. The REPL in the editor in here is quite limited, so it's quite useful to just go in and copy this code into your REPL and play around with it. So we'll do a few of those in future study groups. We'll take a few of the meatier examples and play around with them in the REPL and see what we can do, and see how we would go through the thinking process of solving one of these. All right, I'm going to leave it there. It's another hour and a half. I hope you found that really interesting. And so I've already put up the next lesson. So we have, I'm going to put this on Sunday, the 26th, because on Saturday there's the London Java Community Conference, which I'll also do a Clojure talk on, Clojure workshop on at some point as well. If I'm feeling brave and the Wi-Fi's handling it, I might broadcast that as well. See how we go. So one of the things is doing, that's live now. Where's my, I did have events. There was an event I created. Where's it showing? I'm not showing why. Oh, live now and upcoming. Yes, learning the YouTube one. Here we go. So my idea for the next study group was to walk through coding of a simple application. So we can either do some 4Clojure ones, or we can just come up with an application to just walk through, kind of writing like a fairly simple application, but enough to kind of think about how to design it within the space of an hour. Okay, well, thank you very much for listening. Feel free to go and have a look at my more information in the Clojure study guide. I'll put the details up here in this study guide of what we covered today and links to all the broadcasts. I've got these links to all the recorded broadcasts, and I'll put in like the live and the Hangout links to next week's broadcasts in this page as well, which is just on this study guide, which I'll copy into the comments. There we go. Okay, well, unless anybody's got any final questions, thank you very much for listening, and hope you enjoyed it, and please leave some feedback about what you'd like to see next. Thanks very much. Goodbye.
Thanks, John.
There you go.
Good one.
Oh, there was, just before I go, there was a question about Spacemacs. It's quite easy to update. I'll cover that in the where is it? I could cover that briefly now. If I just jump back to Spacemacs and my screen share, oops. There we go. Screen share. So I'm just hopefully you can see my Spacemacs. Where was the actual question? There is there a way to update Spacemacs to the latest version? So I use Spacemacs develop. So you would have to go into, so if you go into your .emacs.d file, so emacs.d directory, and change the git branch from master to develop, and then restart Spacemacs, it should do that. And then I would just, then I would use git to pull down the latest version. If you're still on develop, you can do space buffer space BH for home, and there's actually an update Spacemacs link. So if you're on the master branch, you can update Spacemacs that way. If you're on the develop branch, then what I do is basically I'll go in and open a file, so space find file. I'll go into .emacs.d and I'll open the README file, and then I'll just open git status, or space GS for my git status, and I can just pull. So there's a whole bunch of ones here, so I can, if I want to pull the latest version down. I'm actually going to do this. I'll do this because I was going to do this anyway afterwards. So I press F. It's asking me where I want them from, so I'm going to do it from origin develop. So press U, and this will pull down the latest version. So it's yeah, you can see the head and the develop. The head is develop and origin develop are the same. So this is my local version, and this is origin develop is my is the remote version. So now they're all the same. So that's updated all the source code, all the eLisp that makes up Emacs, all the configuration. I'm going to quit that, and one important thing to do is this. If I do space FE and then capital D, it will bring up a diff of the .spacemacs configuration file. So I can do N or N and P or J and K to go for the next and previous versions. So my layers are different, which is fine because I've got different layers from the template. But I can check to see if there's any other things that are new. I'm using Ubuntu theme, that's different. I want to keep that. I want to keep the projects. So these are kind of little tweaks I've made myself. So when I open the Scratch buffer, it will give me a little message. I'm going to stick with the Ubuntu mono. So this in red, this slide on the left hand side is my existing .spacemacs file, and on the right hand side is a Spacemacs template. So there might be some new configuration in there that I actually want to apply, but so far I haven't found anything. So my line numbers are different. I use the Vim style relative numbers. It doesn't look like there's anything particularly different this time around, so that's good. There we go. And I'm just pressing N or J to go through the rest of these. So this is actually this package that's running this diff is called ediff. And so you can use this for any files inside Emacs you want as well. And I think that's it. And the rest of it is just this is my own custom configs I've got inside the user.config section, which is obviously going to be different. And then next. And then the Emacs custom settings are going to be different because obviously when you run Emacs or Spacemacs, then it's going to add specific things to that as well. So I've updated Emacs. I've updated Spacemacs via Git for the develop branch. I haven't needed to change anything from the template. And then the final thing to do is to go in and update packages. So if you were just using master branch, you just go into update Spacemacs, and then you would update the packages with if you're using the develop branch, then obviously I'm going to use Git on my Git in this case to update Spacemacs, and then I can just press enter and it'll update the packages as well. So I'll go in and refresh the package list for Melpa, which is the repository for Spacemacs, and then boom, it's showing me all the things that are going to be. So there's quite a few updates. I haven't checked them all, but I know I can roll them all back if it breaks everything really badly. And tomorrow I'm planning on upgrading to Ubuntu 18.10 as well, so it could be quite interesting. Updating
18.04, right? There's no 18.10.
Yeah, 18.10's out now because it's
18.10 is out. LTS.
Yeah, it's been out for a month now. So no, it's not LTS. So it's the next one is LTS, I think. So it's 19.04, I think, is LTS. I think. So Emacs has been updated. So I'm just going to do space.
Cosmic Cuttlefish.
Yeah. It actually, I'm running it on one of my older laptops and it runs really nicely. So I think it's definitely worth kind of putting on this one. But I'll go and try the whole YouTube stuff on there before I update as well. So I'm just gonna restart with layouts. Resume with layouts because I use layouts in quit. Yes, there we go. So that should restart Emacs, and it'll download all the packages for me. If it downloads like quite a lot, which it sounds like it's got 55, I might actually restart Spacemacs just to be sure after it's done this as well. But that's essentially how I would update Spacemacs. So it's you're updating Spacemacs itself and then updating the packages. I usually do those both at the same time. If you so do this when you're not on a deadline, obviously, and so you've got, if there are little bugs, then you can fix it or you can roll back. And yeah, it's worthwhile checking out. If you are on the develop branch, it's worthwhile checking out the packages you use the most, just to check out what new features you've got from there, and if there's anything interesting or any kind of issues that people have raised already. Okay, I'm not going to make you watch all this install, but that's it. Hope you found that useful, and I will see you all next week sometime. Thank you. Bye-bye.
Take care, John. Bye.
Thanks. Bye.